Hello, everybody. Welcome to our session, Transforming Healthcare with AI. My name is Paul Zhao. I'm the product manager for Amazon Transcribe. I'm extremely excited today to have you join us. Welcome. We have a very exciting announcement you may have already heard. We announced a new service called Amazon Transcribe Medical. In this particular session, I'd like to really walk through what it means to use AI to transform healthcare, really take a look at some of the problems that are being faced today by customers, by end users, by builders. And with me today, I have two wonderful guests whom you will hear from, Jacob Gears from Cerner, as well as George Segan from Amgen. I'd like to start off by talking about the challenges of analyzing voice data in healthcare today. There's over 1.5 billion hours of medical data, audio data, that's generated every year. And there's these key insights and valuable pieces of information that's locked inside, trapped, hidden in there because we don't have a great, convenient way to really extract that information. About 90+% of that information is actually generated by physicians alone. So you can imagine just how much audio data, medical audio data we have, and how much of that we're not able to gain deep insights into. And of course, there's even more billions of hours of medical audio backlog that's floating around in all of our databases that we can't actually tap into. To extract information, useful insights from medical audio, you're gonna need to do two things. You're gonna take that audio and you're gonna transcribe it into text, right? That's step number one. To do that, we use automatic speech recognition, ASR for short. Your second step is going to be using natural language processing to run text analytics against that text that's been output by the ASR upstream. What I want to do is quickly dive into that first leg and what Amazon Transcribe Medical can do, and also give you a quick overview of what the service is. But before I talk about that, I want to get into some of the limitations of existing solutions. So a lot of you would be familiar with 3P manual transcription services, right? The limitations here are the fact that there's turnaround time associated. It is and can be quite expensive. Human scribes, you may have walked into a session with your physician, into a hospital in which you weren't just talking with your physician, but actually there was a third person there. He or she was a human scribe whose job is actually to help physicians or clinicians take notes to capture the conversation that's happening. And the limitation here is that it can be awkward for patients, right? You're talking about intimate things about your body, about your health, and yet there's another person there who might be listening in, and although they are silent, it can be awkward and can be a distraction also for clinicians who are trying to deliver better patient outcome, better patient care. For providers, human scribes are difficult to scale. Imagine managing teams of people who are not always full-time staff at their provider facilities. You're probably also aware of front-end dictation software, which is available and commonly used for what we call post-encounter dictation sessions. That means the physician or clinician will spend extra time after each patient encounter and engagement explicitly note-taking. And so what that means is these physicians and clinicians have to spend this extra effort, and there's this burden associated not just with actually delivering good care for patients, but actually doing clerical work. And that really takes away from their experience and introduces things like burnout. Moreover, a lot of these pieces of software that's available today have lock-ins, offer inflexible pricing, and not very, very transparent tracking against actual transcription usage, for instance. And finally, a lot of these types of software require clinicians to work for the software instead of the other way around. For instance, you might have to use unnatural speech, explicitly noting things like commas in punctuation or a period here and period there. And that can be, again, very, very distracting. So I'd like to introduce Amazon Transcribe Medical because there is a better way, and we've built it. Amazon Transcribe Medical is an automatic speech recognition service that gives developers a really, really easy way to add medical speech-to-text to their applications. And there are 4 major use cases I'd like to talk through very, very quickly. The first is in clinical documentation. I've already alluded to this several times already. The notion that a clinician is spending all these burdensome hours and minutes doing documentation instead of actually focusing on the patient. So using Amazon Transcribe Medical, you can actually capture those conversations or dictations on the fly, reducing the burden on physicians. The second one is drug safety or pharmacovigilance. In this example or in this use case, what you'll find is that there's meaningful insights hidden in contact center calls from either clinicians or patients who want to report potential side effects or safety events. The next use case is a growing one in telemedicine, where we're able to use Amazon Transcribe Medical to generate subtitles for sessions that are happening remotely between a physician and a patient. And the fourth is a broader set at the contact center level for payers and providers who actually are generating tons and tons of this medical audio data, these calls that are being recorded. Some of the features and benefits of Amazon Transcribe Medical are that it's highly accurate, it's very, very easy to use, and we've made it so that it is very affordable. So let's blow up each one of these. In terms of accuracy, today we cover US English, and we cover transcription for primary care, which includes the following 4 specialties in OBGYN, family medicine, internal medicine, as well as pediatrics. We're able to not only transcribe dictated notes, we're also able to transcribe conversations between a clinician and a patient, for instance. Transcribe Medical is very, very easy to use. It can be easily integrated with any voice-enabled application. It's device agnostic. It is a real-time API, meaning that you can open a secure WebSocket connection over which you send us an audio stream, and for which you will get in return a text stream in JSON blobs. As I mentioned earlier, we feature natural speech, which means things like punctuation and capitalization are automatically taken care of. No more awkward, explicit dictation of things like commas and periods, semicolons, of that nature. In the transcripts, we also offer word-level timestamps. This is going to be key if you want to do things like traceability, if you want to generate subtitles for that telemedicine encounter, for instance, and be able to map that against the video recording. And then also within the transcript, we offer word-level confidence scores. With that, you get a glimpse into how confident we feel we've done our job in transcribing every single word. Transcribe Medical is very affordable. It offers a pay-as-you-go model, which means there's no lock-ins, there's no contracts, there's no terms. You have the flexibility to pay as you go. More importantly, we charge by transcription usage. So if you wanted better transparency into whether this offering gives you advantages and gives you value at the year end, you can actually map that back to the usage, back to your charge. We're offering it today at 7.5 cents a minute, and everybody who registers will be able to get 60 minutes free tier per month in the first year of registration. So very briefly, I want to talk about how Amazon Transcribe Medical works. Like I said, it's device agnostic. You simply call the API, you start passing your audio stream, and then in return, you get a stream of text. It's basically that simple. And Amazon Transcribe Medical is HIPAA eligible starting today. So we've covered that first leg of that trip, taking audio and transcribing it into text, and then we have to do something with that text. At Amazon, we have a service called Amazon Comprehend Medical, which is our in-house medical NLP service. Last year, the service was launched for the first time, and so I'll just briefly revisit what Amazon Comprehend Medical covers. For those of you who are not familiar, it's a HIPAA-eligible service that uses machine learning to extract medical information with very, very high accuracy to help reduce both the cost and the time and the effort of processing very, very large amounts of information in unstructured text data. Amazon Comprehend Medical is able to offer you an API so that you can determine key entities, and within those entities, determine the relationships We also offer the ability to detect protected health information. So now what I'd like to do is talk about how Amazon Transcribe Medical and Comprehend Medical can be used in conjunction with one another. Whether it's a conversation between clinician and patients or a medical dictation, you pump it through Amazon Transcribe Medical, you get the text in return, and then you take that text and you pump it into Comprehend Medical to run text analysis. With your output, you're welcome to, for instance, pump that into an EHR system, electronic health record system. And for a moment, I'd like to show you a quick demo, stringing both services together.
This 55-year-old man with known coronary artery disease comes for a follow-up visit today. Last month, he was admitted to our hospital with unstable angina. He underwent heart catheterization on November 15, 2007. At that time, he was found to have a tight 99% proximal stenosis, total occlusion and collateralization of the mid-circumflex. Right coronary artery was normal. Ventriculography was normal and his ejection fraction was 65%. He underwent an uncomplicated placement of a ciphered drug-eluting stent to his proximal lesion. The attempted coronary intervention of the circumflex was unsuccessful, as his lesion cannot be crossed. His post-procedure was uncomplicated, and he was discharged on the day following his intervention. He comes today indicating that he is feeling great. His current medications include aspirin, 325 milligrams daily, Lipitor, 40 milligrams daily, and Plavix, 75 milligrams daily.
So what you just saw was an actual real-time transcription of an audio file that I had recorded in advance. You can see from the partial transcripts finally mapping into final transcripts that the quote-unquote thinking is happening on the fly. As each new word is being introduced into the sentence that's being spoken, context is being introduced, and we're able to think on the fly. We take this text that we've generated using Amazon Transcribe Medical, and then we pump it, like I said, into Amazon Comprehend Medical. With that, we can get insight into key terms, such as PHI information. We can highlight medical conditions. We can discover anatomy, and so forth. We can also drill into any of these terms. Maybe we're interested in looking at what the ejection fraction is. Here you can see on the right panel in this quick demo, we've been able to demonstrate the entities and also the relationship to the term 65, and then showcase the unit of measure, which is in percentage. If you'd like, you can even actually show a much more comprehensive view of the entire list and summary of entities and their relationships. Again, this is a really, really bare bone but quick way to show you how we just put two services together. For all the builders out here, this will be easy peasy for you. All right. So again, what you just saw was Transcribe Medical working in conjunction with Comprehend Medical. But the thing is, you can mix and match. You don't have to use Comprehend Medical if you didn't want to. You can use it with your own NLP, medical NLP of your own choice. And with that, I'd love to welcome Jake Gears from Cerner to talk about his use case and also how they're transforming clinician and patient conversations using Amazon Transcribe Medical.
Thanks, Paul. Appreciate it. Hello, everyone. Welcome. Thank you for coming and spending a few minutes with me this afternoon. I want to start out with a story, and this is actually a true story. So 2 weeks ago, I had to take my 15-month-old daughter to the doctor. She had an ear infection a couple weeks prior to that, and it seemed like her conditions were worsening. I had to take along my 3-year-old. My 6-year-old was in school. So I had my hands full. And I'm in with the doctor and in with the EMA, and I'm probably the 20th patient they've seen that day, and they probably have 20 more patients to see after me. And they examine my daughter. She's screaming because she doesn't like things being stuck in her ear. And the doctor's asking me questions, and the doctor's busy in front of her computer typing in data and looking up data, and it's just a very kind of stressful environment. So the visit happens, we get home, and my wife starts peppering me with questions. What happened? Are both ears infected still, or is it just one ear? Does she need a new medication, or should we finish out the old antibiotic? Do we need to get referred to an ENT doc because she's had several ear infections this month? So I was not able to answer all of those questions, and research backs me up on that we only retain 20 or 30% of something when we're talking to a professional in which we're not skilled in that particular area, like something like medicine. So that is where we are building at Cerner a solution called Virtual Scribe, helping clinicians get through their day in a much more efficient and easy manner. And it also helps patients. Imagine if I were able to take a summary or a transcript of that visit to be able to answer those questions or have my wife review that in more detail. So we are Cerner Corporation. We are a leading global EMR provider. We also have a population health platform. We are 29,000 associates strong. We're live in more than 35 countries. So we're a huge, huge player in the health IT space. We chose to expand upon our relationship with AWS. We've been working with them since 2009. We signed a major deal with them earlier this year to help us really get to that next level in healthcare. So our clients have been putting data in EHRs for 10, 20, 30 years, and they've not really been able to glean the power of the promise of an EHR, which is to gain insights from all of that data that we have in the EMR, most of which is unstructured. So AWS is going to help us with a variety of ways, but they'll really help us unlock all of that data and allow us to embed that into workflows to help clinicians. So our vision is really one where we transform a world today where data in, documentation in, is both tedious and time-consuming. And then that decision-making is also very manual. To get data out of a system, you have to write a report. Or to get data out, you have to hunt and peck and go look for actual data. We want to transition into a world where data in is heavily automated from voice, device data, and consumer-entered information. And we also want to have decision-making be guided by AI and virtual assistants that are continuously scanning through that record and providing real-time insights. All that being said, as we focus on reducing cognitive load, we have some very important guiding principles. One of which is that we are not a black box. We are showing all of our work by including context. As we demo Virtual Scribe, we will show you right alongside the proposed clinical terms where in the conversation that came from. So that clinician, as they're seeing 35 or 40 patients per day, they don't have to remember, did the patient say they had chest pain or did they say they did not have chest pain? Was it a stabbing pain or a shooting pain? Virtual Scribe is capturing all of that, keeping a scratch pad of that visit. We also make sure that we leave the medical decision-making to the clinician. In order for clinicians to trust these new technologies, these machine learning models, these artificial intelligence pieces, they need to be able to trust that we are showing them the value and showing them the work behind it. So we need to show, before we recommend something, why we came up to that recommendation. And then finally, we're going to deeply embed that in the workflow. We're not going to make them change screens. We're not going to make them utilize a bunch of mouse miles and add a bunch of clicks to their workflow. We're going to deeply embed it, and it's going to be right there front and center for them to go on with their day. So I'm just going to really quickly explore some of the challenges of clinical documentation. There's a lot of press out there around clinician burnout and physician burnout. The studies show that clinicians spend almost double the amount of time in the EHR documenting on their patients than they do actually seeing the patients. We want to flip that on its head. Physicians and clinicians got into medicine because they like caring for patients. It's in their DNA. So we feel that we should be able to leverage artificial intelligence, machine learning, natural language processing, automatic speech recognition to enable them to actually provide care for the patient. So today, a lot of times, clinicians are not going and entering family history and social history, smoking status into those particular sections. They're picking up that awkward microphone that Paul talked about, and they're saying, patient is a non-smoker, or patient smokes 3 packs per day. And then that data is buried inside a note. With leveraging Cerner's virtual scribe, powered by AWS Transcribe Medical, and using Cerner's NLP, we can actually codify that and put that into the right spot in the record, driving a whole bunch of benefits downstream. Clinicians want to care for patients, and clinicians also want to work at the top of their licensure. A doctor does not want to be in front of a computer. A doctor wants to be caring for patients. And finally, providers want their notes created as a byproduct of the visit. They do not want to do pajama time, which is documenting at the end of their day, taking care of all of the notes and all of the regulatory things that they need to go and have done. They want to leave at 5 o'clock like we all do, so they can go watch their kids play soccer or spend time with their wife or do something with it just for fun. So that brings us into leveraging voice. So we've had keyboard and mouse. We've had touchscreens, very successful user interface on our mobile phones and tablets. But really, I think for healthcare specifically, voice is extremely powerful. Healthcare is often a very sterile environment where clinicians are using their hands constantly, so voice is very natural. So across the care continuum, whether that be in the OR suite, whether it's in a hospital room, whether it's in a doctor's office, or whether it's the patient at home, there are numerous examples where voice lends itself really well. I've mentioned this theme several times about reducing the cognitive load on healthcare teams. One of the ways that we're diving deep on today is around voice. But you can also use images, videos, and sensors as different inputs. And then you apply the AI transformations to that. So I'll use an example. If I was talking with my doctor and I said that I had blood in my urine, we would take that and we would obviously get the text of that. We would get that blob of text from Paul's Transcribe medical service. And then we would apply natural language processing on that and also natural language understanding because we need that context. And then we apply ontologies, mappings, and terminologies to that. So the blood in the urine, there's a SNOMED code for that. So that's important. Blood in the urine is also known as hematuria. And there's an ICD-10 code for that, which is needed for providers to do their billing. So we take all of that, we apply the semantic interoperability to that, and then we give that to the clinician in the form of an application, deeply embedded in their workflow. And I'll show you exactly what that is when we do our demo. So with Virtual Scribe, the clinician simply needs to conduct the patient visit, and Virtual Scribe does the rest. We give you a conversational transcript generation in real time. We codify the conversation using NLP and NLU, and we support 17 different healthcare concepts. We allow the clinician to directly add things to the EHR. So things like allergies, medications, and problems are things we support directly today and discreetly today. And then we also allow them to incorporate the transcript directly into their clinical documentation. So those allergies that come back, with one click, they can add those to the record. They're codified in that allergy profile so that any clinician and any time downstream that needs to be referenced, those are then available. Medications can be added as a brand new prescription to go out to Walgreens or CVS. They can also be added as a historical med. A lot of times a patient will say, yeah, I'm taking a multivitamin. That needs to be documented, that needs to be added to the medication list, and that's just a home med. So you can add that as well directly from here. And having it captured by the conversation, the provider doesn't have to go and search for that. They can focus solely on the patient. They no longer have to do that context switching. That saves them time per patient. It results in more complete documentation. It reduces clinician burnout. And it definitely increases patient and clinician satisfaction. I know that I would definitely feel more comfortable talking to my provider if they're able to look at me and focus on me the entire time, instead of transitioning back and forth to and from their computer, finding the problem list, clicking in the add button, starting to type the name of the problem, choosing the problem, clicking add. all of that is eliminated through the use of voice technology. So where is this headed? Ultimately, what our providers are telling us is, this is fantastic. I also want it to generate a note for me. So at the end of my visit, I want you to propose a note to me and me to say, yep, that looks good, or do a couple of tweaks to it and go on with my next patient so that I can get out of there at the end of my day. We can also do all kinds of things like automated patient summaries. So those questions that my wife was asking me, I would be able to show her a summarization of that, or show her the entire transcript of that. Additionally, there's a lot of documentation that nurses do and MAs do that voice can be leveraged for, that we can tie the specific value to the specific form, and we can complete form charting as well through voice. So how does this work? Paul talked about this a little bit. I'm gonna kind of share how we're doing it. So we clip a microphone onto the laptop that the clinicians use when they're seeing the patients. They log in, there's a microphone on the toolbar. The patient and the provider have their conversation. We have our SDK that's sitting locally with Citrix. That passes through to the cloud, where we have our concept service and our speech service running. And those pass those blobs, those JSON blobs and those APIs back between Amazon Transcribe Medical and then Cerner's NLP and NLU engine. So I'm going to play a quick video to illustrate Virtual Scribe in action. On the left side, you will see the interaction that occurred between a patient and a provider, and on the right side, you will see the suggestions that get teed up for the provider, that scratch pad, if you will, that they are able to then take action on.
Hey, Dr. Nadeau.
What brings you in today?
Well, I've been kind of feeling a little down lately. My asthma's been acting up, and my albuterol's not really working. I don't know, I just feel kind of depressed.
Well, let's see what we can do for you. So I saw you were already taking Wellbutrin 150 milligrams daily. What happened with that medication?
I was getting really dizzy, and I started getting really bad dry mouth, so I stopped taking it.
How is your sleep?
Not good. I was getting 8 hours, and now I'm lucky to get 2.
Well, why don't we do some changing on your medications? Do you have allergies to medicines that I should know about?
I'm allergic to shellfish, but I'm pretty careful about it.
Okay, let's switch your medications. I want you to stop your Wellbutrin, start Prozac 20 milligrams in the morning, and then at bedtime for sleep, take Seroquel 25 milligrams. Remember, that is a sedative, so be careful with that. And then I'll see you back in about a month, and we'll go over your progress. If things aren't better, we can always incorporate therapy at that time, okay? So how's that sound?
That sounds great. Thanks, Dr. Nadeau.
Great.
So what you saw return there on the screen was not only the proposed actions, but also a transcript. So the user interface is very, very simple. We have the medications, the problems, the allergies sectioned out. With one click, we allow those additions right into the workflow. If you don't agree with those, or those weren't exactly what you thought, or exactly what you wanted, or they weren't relevant, you can simply ignore them. And then we show you the entire transcript that you could highlight, utilize, take, edit, and incorporate into your clinical documentation. As I mentioned before, one of our guiding principles is that we're going to deeply embed it into the workflow. So on the right side, you have the elements of your notes section. On the left side, you have your chart data. And right in the middle sits Virtual Scribe, allowing you to take information, add it directly to the chart, or take that information, drag it, drop it into your documentation sections. Very, very easy, very, very user-friendly. Again, access to both that transcript as well as those proposed actions that are being returned. So the tests that we've done show that this will result in a significant reduction in the amount of time spent documenting the allergies, the medications, and the problems. It allows your staff to shift to focus on patient care, preventative items, as well as all of the regulatory burdens that are being asked of clinicians, ultimately leading to increased provider satisfaction and increased patient satisfaction, reducing that clinician burnout. So Virtual Scribe listens so that I can focus on the patient. That's the ultimate benefit. That's why I got into medicine, so that I can focus and care for patients. So where are we in this journey? We are testing this with a couple of our clients. We have many more signed up to test with us. We're on the journey to augmented note creation. So we're collaborating closely with the AWS Transcribe medical team to solve for all of these things. So speech-to-text accuracy, increasing that. Making sure that all the medical terms across all of the different specialties are accounted for. Understanding, is it the patient that just spoke that, or is it the clinician that just spoke that? That's really important for us to return those proposed actions that I showed you in the video. And then making sense of the clinical context. So if I say to the doctor that my grandma had congestive heart failure, today we will return congestive heart failure as a proposed problem. It's not really a problem, it's a piece of family history. So that's where context is extremely important. And then we need to take all of that and we need to form it into sentences that a clinician would put into a readable note. So it's definitely a journey. We're working very closely with AWS to make this a reality. So again, just a little bit of a wrap up. More and more is being asked of clinicians each and every day. Documentation is very tedious and time consuming. So we created Virtual Scribe with Cerner AI that passively listens to healthcare visits, captures discrete data, allowing clinicians to focus on the patient and not entering tedious data into the EHR. Cerner is relentlessly focused on seeking breakthrough innovation that will shape the healthcare of tomorrow, because healthcare is absolutely too important to stay the same. So with that, I will wrap.
Thank you, Jake. Please allow me to introduce George Segan from Amgen.
Hello, everybody. Let me tell you a little bit about Amgen for those of you who don't know who we are. We're one of the world's largest biotechnology companies. We have a global footprint for research and development, a global footprint for biotechnology manufacturing. We're serving millions of patients in over 100 countries. Oops. Sorry, I didn't have that up on the screen, I guess. We're a fully integrated biotechnology company with world-class capabilities in a number of areas. Due to our history in biotechnology, we have deep expertise in protein engineering and biologics manufacturing. We also have a history that gives us a biology-first advantage in that we have a number of different biological modalities that we can apply to look at any given possible therapeutic target and develop the appropriate therapies to address that target. In addition, our Decode Genetics facility in Iceland is one of the premier research facilities for human genetics in the world. We take much of the information that comes out of that operation and use it to validate the therapeutic targets and the proposed therapies that we're looking at. At Amgen, we really focus on grievous illnesses and trying to find innovative solutions or biotechnology therapies to address those illnesses. Some of the major therapeutic areas that we focus on is cardiovascular disease, bone health, inflammation, and oncology. Here are a few of our products. You may have heard of some of them. Things like Enbrel for rheumatoid arthritis, Repathic for cardiovascular disease, and Aimovig for migraine headaches. And what I want to talk to you about today is some work we've been doing using machine learning to help us identify safety events as part of our pharmacovigilance programs. About a year ago, we started a series of experiments to see how well we could do with the latest NLP technologies to develop machine learning tools to identify safety events in the interactions we have with healthcare providers and with patients. And in addition to that, we currently have a large effort or a large staff of trained healthcare professionals that actually interact with patients and healthcare providers can call us in and actually do human curated transcription of the conversations that are going on that we can base our pharmacovigilance efforts upon. We also wanted to start looking at using machine translation in this area and seeing how far we could push the technology there as well. We started out capturing a large amount of human-curated transcription information from our historical systems, or out of our existing systems, and developed a series of NLP models, a whole, not one or two, but 10 NLP models to help see how well we could do identifying these safety events. They employed both traditional linguistic approaches and also deep learning approaches. And we're very encouraged that the top performing models actually perform quite well. This is an architectural diagram of the system we used at Amazon. All of the model training and all of the model inference was actually done on the Amazon SageMaker platform. All of our raw data and model artifacts were stored in S3 buckets. And here's a little bit of the a few results from what we saw, or what we obtained from the different models. And it doesn't really show on here, but we also used Amazon Comprehend inside a number of the models as a feature generator. But the best performing models were models that depended on word vector embeddings and different types of deep neural network classification layers. And with a couple of the models, we were able to achieve overall accuracies, precision, recall, and AUCs up at the 98% level, which was quite gratifying and quite useful. At the same time, we initiated a set of studies to use Amazon Transcribe to do machine transcription of the audio events themselves and compare it to the human transcriptions that we were also working with. To nobody's surprise, Amazon Transcribe out of the box was not able to recognize a lot of the specialized medical vocabulary that was contained in our data sets. To get around that, we actually started building custom medical vocabularies of our own that we could use to supplement the Amazon Transcribe vocabularies. A number of we constructed these vocabularies by going to a number of the medical coding systems that are out there that are publicly available, things like ICD-9, ICD-10, CPT, HCPCS, the National Drug Coding System, and even the SNOMED ontologies. And we took the descriptions out of all those coding systems and created a massive medical vocabulary. And as we expected, the performance with Amazon Transcribe, when we added that supplemental vocabulary, improved tremendously. But there's still room for improvement. At that point, we got connected with Paul and the medical transcribe team, and since that point, we've been using medical transcribe and seen further significant improvements in performance for our medical transcription of our HCP and patient interaction data. So where are we at currently? Well, we've completed a lot of work with our human-curated transcriptions and built a number of models that perform actually excellently in that area. We're right now repeating all of that work with Amazon Transcribe Medical and actually building some even more advanced models that are transformer-based models that have recently become, that their architectures have recently become available. And we're comparing the performance on all three systems, and hopefully we'll be very quickly at a point where we can start putting some of these tools into usage. And why is this important? What are the benefits out of this? The current manual approach that we use is really difficult to scale. And any tool that we can produce here doesn't have to be comprehensive and cover everything. If we can simply accurately identify certain amounts of certain items that don't need to be looked at, that will be a major win for us. In addition, many of the safety events that we're looking for are rare. And we're looking for them in places like the medical and scientific literature, whose volume is increasing tremendously. What we're hoping is that some of these automated tools will help us find those needles in those haystacks that are just increasing in size daily. And finally, there's a huge interest in using some of the new voice-enabled technologies that are becoming available, where human-in-the-loop just isn't going to work, or it would be very difficult, or probably won't even work. I'm speaking about things like chatbots. We're hoping the automation tools that we're developing for identifying these events will be very useful in that situation as well. Thank you very much.
Thank you, George. So with Jake, you heard how Cerner is using virtual Scribe to really transform the way that physician-patient conversations are being captured, are going to be analyzed downstream, are going to be used either to enrich a patient's understanding of his or her own healthcare, or to really save time and lift the burden off the shoulders of clinicians themselves. With George, you heard how Amgen is really innovating new ways to tackle the use case for pharmacovigilance, not only in identifying safety events, but actually identifying things that are not relevant to spend time on, right? The other side of the coin. So I wanted to thank both our guests very much today, and thank everybody here for coming. Amazon Transcribe Medical is available across 6 major AWS regions. If you have any other questions, the 3 of us will be available after the session to take some questions. And thank you again. Here are some related sessions that you're welcome to attend. We also have another chart. We'll keep both on screen to share with you additional healthcare sessions as well. Thank you very much.